Hi everyone, today we're going to be talking about section 9.1, matrix solutions to linear systems. So I have a warm-up for us here first. We'll just do it together. So we're going to be solving the system using either elimination or substitution. I think elimination is probably the easier route because the y's are going to cancel out right there. So when I add these together, I get 5x equals 20. And solving for x gives me 4. Now, of course, we have to plug that back into one of the equations in order to solve for y. So I'm going to plug that in for x. Let's just use the bottom equation. So we've got 4 plus 2y equals 12. Solving for y, we get y equals 4 as well. Okay, so kind of a straightforward system here. We've got 4, 4 as our final answer. Okay, now today we're going to be talking about matrices, which is the plural of this word matrix. So what is a matrix? It is a rectangular arrangement of numbers in rows and columns. So plural would be matrices. Sometimes you'll see that. Okay, so let's say we have a 2 by 3 matrix. That means 2 rows and 3 columns. So let's say we have something that looks like this, and I'm just going to throw some random numbers in there. 1, 2, 7, 0, 5, 3. Okay, so this would be considered a 2 by 3. Okay, 3 by 5 would have 3 rows, 5 columns. I'm not going to draw that. You guys can picture it. But it always goes rows first and then columns. So always remember that it's always R, C in that order. Okay, so rows are horizontal, columns are vertical. Okay, so entries are the individual numbers in the matrix. So for example, 1 is an entry, -2 is an entry. So the dimension of this particular matrix, it's got 3 rows and it's got 2 columns. So it would be 3 by 2. When I'm asking for a specific entry, that's what's going on over here. It's telling us which matrix, so it's matrix A. We want the first row, and again, it's always going to be row, comma, column. So my first row, my second column, that would be this number over here, -2, because that is in the first row and it's in the second column. Third row, first column would be 0. Okay, so we're just talking about the individual numbers in there. Finally, sometimes you'll see these two. They don't happen that often, that we refer to them at least, but if we're talking about a row matrix, it's just a single row. If we're talking about a column matrix, it's just a single column. Okay, so that's basically it. Now, if we're talking about matrices being equal to each other, that means all corresponding entries must be equal. Okay, so they have to have the same dimensions. So notice that we have a 2 by 2. This one's also a 2 by 2. Okay, and all of the corresponding entries have to be the same. So top left are both 5. 0 and 0, those are both the same. -4 over 4, well, that simplifies to -1, which is what I have here. 3/4, 0.75, those are equivalent values as well. So our answer would be yes. Okay, this is going to come in handy later on when we start solving matrix equations. Okay, now what is the purpose of a matrix? I know we've seen these arrangements. They're rectangular shapes of numbers. The reason why we like to use matrices is that they can represent a system of linear equations. Okay, so if I have the same system as our warm-up, okay, I just rewrote it over here. I can write it 2 different ways. The first method is called a matrix equation, and it looks a little something like this. Okay, So I'm gonna put a couple of brackets here. And what's gonna go into this matrix are all of the coefficients. I'm gonna call this the coefficient matrix. Okay, so our coefficients in order. So I've got 4, -2 up top, 1 and 2 on the bottom. Okay, and then our next matrix are the variables. Well, the variables in order are x and y, and we always put them in a column. So this is called our variable matrix. And that's going to be equal to the numbers over on this side, which are 8 and 12, again, kind of in order. This is called our constant matrix. Okay, so this is, again, a matrix equation. We're going to be solving these later in this chapter. Okay, so matrix equations, these are going to be later on. In today's section, we're going to be talking about augmented matrices. Okay, so they look a little bit different, but pretty straightforward to use once we get to that point. So we're actually going to make a slightly bigger single matrix. So it's just one single matrix. And we're going to write just a vertical bar over on the right-hand side, sort of. Okay, so we're still going to have the coefficients on this left side, 4, -2, 1 and 2. On the right-hand side, we have our constants. So coefficients, constants. Okay. The nice thing about an augmented matrix is that if you have a single system like this, it's really just one matrix you're going to be creating in your calculator, and there's just one step that you're going to have to do. Okay. All right, so let's jump to the next page. And I'm going to pause the video here. You guys can take a look at this system. Okay, use the previous example as a model, and I want you guys to write the system as an augmented matrix. Okay, so just as an augmented matrix, we're not going to be setting up a matrix equation necessarily in this section. So go ahead and press pause and try that problem. Okay, go ahead and check your solutions up here. So we've got our coefficients on the left-hand side and the constants on the right-hand side. Okay, now before we get to actually solving, I want to talk a little bit about some more things that we can do within an augmented matrix, or really any matrix. So these are matrix row operations. Okay, so when you guys see notation that looks like this, okay, so row I, row J, a lot of times you'll see numbers. For example, row 1 and row 2. This means you're just switching the numbers in the rows, okay? So for example, if I were to switch rows 1 and 2 in this particular matrix up top, I would literally flip-flop all of the numbers so that this first row is now the second, and then the second becomes the first. They just flip, okay? If you have a number sitting in the front, so K times R sub I, so let's say I had 2 times row 1. That would mean you multiply each element in the ith row, or in this case, in the first row, by K. You're just multiplying everything by 2 in this case, okay? And our last scenario looks something like this. So K times Ri, that means you're multiplying K times the first row, and you're adding it to the elements in the second row. So for example, let's do this. Let's say I have, we'll just do this, 2R1 plus R2, and that turns into R2. This arrow at the end means that it becomes the first row. We'll call it the ith row. In this case, I like using numbers. It just makes a little bit more sense. That means we're taking 2 times the first, actually, let's call this, it turns into R sub 1, just so it matches our model. Okay, so we take 2 times the first row, add it to the second row, and that becomes, actually I think this would make more sense, and it would become the second row. Okay, now we're going to actually do all of these with the example below, and it might make a little bit more sense. Okay, so let's take a look at example 2. So our first operation says to just switch the first and second rows. Remember, this is R1, R2, and R3, right? So if I were to draw my new augmented matrix, my second row becomes the first, and my first becomes the second. So I'm going to start with 1, 2, -3, and 5. My first row gets switched to the second. Got a scribble there. -12. And nothing happened to the third row, so I keep that the same. Okay. Now, our second thing that we're asked to do is say, okay, what if we have 1/3 times the first row? I'm going to go back to the original problem and say, okay, I'm going to multiply all of these numbers in the first row by 1/3. Lucky for us, they're all divisible by 3, so it makes it a little bit easier. So notice we multiplied each number in the first row by 1/3. Nothing is happening in the rest of the matrix. Now the reason why we're able to do this is because it's kind of like having a balanced equation. Whatever we do to the left side, we're doing to the right side. So we're keeping the equation balanced, we're just reducing it. And that's exactly what's happening here, is that we're reducing. Okay, whereas in this first step, we're just flip-flopping the equations. Remember that when you have a system of equations, I'm gonna look up here, I can flip these two. I can say, okay, let's put this equation up top, let's put the top equation in the middle, and it would still be the exact same system. We would still end up with the exact same answers. Okay, so nothing is going to change in terms of our final answers, but we're changing what things look like. Now, finally, this last one has a couple things going on, so let's go ahead and look and see. Let's just draw. Okay, so that's going to be our final answer. Now, we're taking twice the middle row, and we're adding it to the third row, and that becomes the third row. This tells us, this right here, is the row we're determining. So really, we're not changing the first row at all. We're not changing the second row. We're changing the numbers in the third row, okay? So as of right now, I can just rewrite the first row. And the second row. And what we're gonna be doing is changing the third row. So we're gonna take 2 times the second row, so 2 times this number is 2, and add it to this number. So that would give me 0. Next, 2 times this number is 4. Add it to this value, and I get 1. 2 times this is -6, plus 4 is -2. 2 times 5 is 10. Add it to -6 is 4. And that would be our final augmented matrix. Now we still haven't solved anything. There is a method of solving a system using augmented matrices and doing everything by hand. And if we had more time, I would show you guys how to do that. If we had time in class, it does take a lot of practice. At this point, I'm okay if you guys can just do a single operation like any of these and just be done with it. And the rest of it will just be in a calculator. Okay, so for example, I want you guys to have your calculator ready. And we're gonna be setting up our system of 3 variables. And we're gonna use an augmented matrix to solve this. So let's first set up our augmented matrix. So I'm gonna put my coefficients in. I've got 1, 1, -1. Constant is -2. 2, -1, 1. Constant is 5. -1, 2, 2. The constant is 1. Okay. So what we're going to be using is reduced row echelon form, RREF, to solve the system. Now, if we were to reduce this by hand, essentially we would be using our processes from up here to make the matrix look a certain way. And we'll see what that looks like in the calculator instead of doing it by hand, okay? So the calculator steps, what I'm gonna do, let's see if we could fit these both. Okay, I'll be writing down the steps as we go. So the first thing we need to do is see the matrix button. So our matrix button is right over here. So we're gonna hit second matrix, okay? So I'm going to, actually let's write that down first. Second matrix, okay? Now we need to edit. Notice I have a 3x4 matrix in here right now. I need to edit that matrix. Actually, let's clear it out just in case. You guys probably don't have one in there. But even if you do, you guys can go ahead and type in 3x4. Actually, I'm gonna clear this out just so you guys can see it from scratch. Give me 1 second. If you ever wanna delete a matrix, you have to go into the memory of the calculator. So I'm gonna hit second memory. And memory management and delete. And I'm gonna go down to matrix. So let's delete that. It's kind of a long-winded way to delete the matrix. Normally you won't have to do that. You can just edit the matrix that's currently in there, okay? So right now we're gonna hit edit and then enter the matrix. Okay, so in this case, we have a 3-row, 4-column. And you'll notice that you only see 3x3, but that's because you have to keep scrolling over. Okay, so if you move to the right, you'll see that last row. Okay, or I'm sorry, that last column. So now we're just gonna type all these numbers in. So if you hit enter after each entry, it goes to the next one over. Okay, so that's my constant I'm putting in, -2. Jumps me down to the second row. So the fastest way to do this is to just hit enter after every single entry. Okay, so we have something like this, okay? So now we can just quit out of there. So second quit. Okay, so now we're gonna go back into the matrix menu. So second matrix. This time we're gonna go to math, which is that second column. And we're gonna go all the way down until you see RREF. Okay, now your numbers and letters might be different from mine, which is why I'm not gonna put B colon RREF. You're just looking for RREF parentheses. Okay, so we're gonna go ahead and select that. And then we're going to go back in the matrix menu to enter the matrix. Actually, I shouldn't use that terminology. To insert matrix A. Okay, so we're gonna go back into the matrix menu, and from the names page, we're just gonna hit enter. And you'll notice now we have RREF and matrix A. So if you hit enter, you'll notice that we get something that looks like this. Now I'm gonna write this in over here. 1 0 0 0 1 0 0 0 1, and then on the right hand side I have 1 -1 and 2. Okay. Now, what does this all mean? This on the left-hand side is what we call reduced row echelon form. This is something we could have come up with on our own by hand if we had done a lot of these types of operations onto the matrix by hand. We're never going to be doing that in this class together, okay? And honestly, at this point, we're not using the left-hand side for anything. On the right-hand side, these are the variables. So the variables are always going to go in order that they appeared in the equation. So that's going to be my x value, that's going to be my y value, and that's going to be my z value. Now the reason why that happens is because notice we have a 1, it corresponds with the x. That means 1x equals 1. This corresponds with y. 1y equals -1. 1z equals 2. So my solutions here come from the right-hand side. So I can write this as an ordered triple. And there we go. Now, if you remember back to last chapter, we had solved systems with 3 variables by hand, and we used elimination substitution. It took like half of a page for us to do. At this point, using our calculator jumps us to our final solution without having to graph, just by using the matrix. Okay, now I want to do one more together before I let you guys try a couple on your own. So let's jump to the next page. Okay, and we've got 3 problems on here. First one is in 2 variables. Okay, so we can actually do that one for practice. So if I'm setting up the augmented matrix, I've got my coefficients and my constant. My coefficients and my constant. Okay, so we're going to be typing this into our calculator. So I'm going to go into the matrix. edit matrix A. Now I've got, this is 2 rows by 3 columns. So this is a 2 by 3. It's really important that you guys have the correct dimensions in. Typing our values in. Okay, gonna quit out of there. Gonna find my RREF. Matrix A. And we end up with our reduced row echelon form. And remember that these final 2 numbers are the solutions. So I would be okay with you guys jumping to the final answer as being x equals 4, y equals 4, and write it as an ordered pair. Okay. When you guys are doing the work for these, I expect you to show the augmented matrix and also the final answer as an ordered pair or ordered triple. Okay. You'll notice that this was the exact same problem in the warm-up, and we didn't have to do any algebraic work. We got the exact same answer. Okay. So if you guys try these next couple, I will post the worked out solutions in the scanned copy of the notes. That'll get posted today. All right. So if you guys have any questions, feel free to call into office hours either today or tomorrow. Have a great day.